Okay, previously we introduced the syntax of simple logic sentences and compound logic sentences. And if you remember, there were 5 types. There were negations, conjunctions, disjunctions, implications, and biconditional implications. Those were the types of compound sentences. And now I'm going to talk about complex sentences. So I'm going to start with the simplest possible complex sentence. And I'm going to tell you that the constituents of the sentences within any compound sentence can be simple sentences, or they themselves can be compound sentences. So what does that mean? This is a compound sentence here because it is an implication that has an antecedent and a consequent. Now, okay, so the antecedent here, if you'll notice, is a disjunction. So the antecedent itself is a compound sentence. So this is a complex sentence. Actually, there's some ambiguity here. So what I just described, I'm assuming that when I write this sentence, what I mean is if P or Q, then R. But another possible way to interpret that sentence would be P or if Q, then R. So this sentence right here does not make it immediately clear whether I mean this or whether I mean this. So there's ambiguity in the syntax here. And so to remedy that, we're going to determine by convention a set of operator precedents. So what order do we apply the operators in? So the highest order of application is negation. So by that, and I'll use this symbol here or this symbol here to represent negation. The next order of application is conjunction. I'll use the caret or the ampersand to represent conjunction. Whoops. And disjunction is the third level of precedence. Upside down caret or vertical line represents that. And implication, either pointing to the left or pointing to the right. Implication will be the 4th level, and the final level will be biconditional implication. So that's the order that we apply the operators in, and based on that precedence, which by the way is convention, then these two sentences mean the same thing. So when I write this, I mean this. Sometimes, especially when you're starting with beginning students, it's good to write this just to emphasize, but eventually you're going to want to start writing it like this so that they start to realize, oh, I have to look at the order of operations. Okay, moving on. How do we go about building a truth table for a compound sentence? Okay, so I'll use for actually a complex sentence. So I'm going to use as an example this sentence right here that I was just talking about. P or Q implies R. Remember, it's the disjunction that's the antecedent, and R, which is the consequent. This is a logic sentence, and I'm going to call it a complex logic sentence, even though it's not that complex. And remember, this sentence can have a truth value of true or false. So if there are n propositional constants, there will be 2 to the n possible truth assignments. Should have your students prove that to themselves. I have an activity for that. So in our case, we have 3 proposition constants. They are P, Q, and R. And that means we'll have 2 to the 3rd or 8 cases. So to build an 8-case truth table, here's a trick. You're going to start by writing down 4 truths and 4 falses. In other words, divide the cases in half, make the first half true and the second half false. Then move to the next column and make true, true, false, false, true, true, false, false. And finally in the last column do true, false, true, false, true, false, true, false. Now when you first introduce this idea to students, you can have them come up with all the possible cases or all the possible combinations of true and false for P, Q, and R. It'll take them a little while, and they probably won't put them in a specific order, and some of them might not get all of them, but as a group they should come up with these 8. It's not that hard. But going forward, using this trick to make sure you get all 8, by the way, this is all 8 possible combinations of the truth values for those 3 proposition constants. All right. Determine the truth value of that first constituent sentence. Now, I want to remind you, or let me go back here. The first constituent sentence is P or Q. That's what I've written right here. That's P or Q. That's the antecedent here in the implications sentence. And remember from our statements, P or Q is only false when both of the both of the disjuncts are false. So where are both P and Q false? The only place is here and here, those 2 cases, 7 and 8. So in only those 2 cases will the disjunction be false. Every other case it's true. Okay? Now you want to determine the truth value of the sentence, the entire sentence. So reminding ourselves, okay, an implication is only false when the antecedent is true and the consequent is false simultaneously. So remember, those statements are really valuable. So I'm going to highlight in pink here, that's the antecedent, and in purple, that's the consequent. So we're looking for cases where the antecedent is true, but the consequent is false. I see a case here, that means the sentence will be false. I see another case here, also the sentence will be false. And I see another case here. Those are the only 3 cases where the antecedent is true and the consequent is false. Every other case will be true for the sentence. This is a really valuable way to evaluate or to fill out truth tables for complex sentences. So which truth assignments will satisfy the sentence? Well, there's case 1, 3, 5, 7, and 8 will satisfy the sentence. And when we say satisfy the sentence, what we mean is will make the sentence true. So there are 5 cases that satisfy the sentence. Another way to say that is there are 5 different truth assignments that will make the sentence true.